Hello guys and welcome. So in this video, we will be training YOLOV4 object detector on a custom dataset. Alright. So without wasting any time, let's straight dive into the implementation. So in this video, we will be using a free Google Colab session, which will provide us with a cool GPU to train our YOLOV4 object detector. Alright. So let's straight dive in. So first of all, we need to clone this repository in any folder you like. So I'll provide all the links in the description of this video. So just go to your project, go to any folder and clone this repository. So I'll say git clone. This is my repository which I trained YOLOV5 on a previous video. So you need to download, you need to clone this repository in order to prepare your dataset. Okay. So the dataset is the most crucial part of this project because we need to convert the dataset into the YOLOV4 format. Okay, it has been cloned. So what you need to do next is that you need to download any class you want, right, for object detection. So for this tutorial, I will be using a number plate detection dataset. Okay, so you can go here like Google Images. What was that? Google Open Images V6. So this is a great site for already prepared dataset for object detection and instance segmentation. So you can see here, if you change the type to detection, it will show you all the detection dataset. As you can see, watermelon. So for this tutorial, I will be using, I think it's vehicle registration plate dataset. Yes, this is a dataset I will be using for this tutorial to train our YOLOV4 object detector. Cool. So what you need to do next is just go to your folder. Just make sure you are in this folder, right? YOLOV5 on custom dataset. For this video, you can go to my channel and search for this video. All right. So yeah, let's continue. So the next step is to cd train. You need to be inside that folder in order to download the dataset. So the next step is to download it. So there's a command saying that python main.py downloader, and the classes, I'll say vehicle registration plate. Okay, and next is the type of CSV we want to download. That is the train. We want to download the train dataset, and let's say I just want to download 1000 images. All right, cool. And for multi classes, you can just do another argument. Let's say multi class is equal multi-class is 1. All right, so this will download all the classes that you mentioned here into one folder. All right, but right now I don't need to do that because I'm already training on one single class, that is the vehicle registration plate. So just hit enter. Okay, so it says, okay, so I need to change my environment first. Also, I need to change my Anaconda prompt instead of the normal command prompt. Okay, so I'll say Anaconda prompt. Okay, cool. So I'll go to my F and CD. Okay, so oh sorry, it's E, not F. CD project training. Okay, so here, okay, I think I need to write that command again. So yeah, I've written the command. Now let's just hit enter and download our dataset. So just press Y, just it will download necessary files. So yeah, as you can see, the train set has been downloaded successfully, and I will show you what it looks like. Okay, you just go into the OID folder, dataset, train. So this is what we have downloaded, right? Vehicle registration plate. So this will look like this. You will have images, all the images here, and the labels in a separate folder. All right, these are the labels. I'll show it to you. Vehicle registration plate. This corresponds to a class, that is our only class, and these are the coordinates x, y, and wh coordinates. Okay, the bounding boxes. Cool. Now we need to download the validation set also. Okay, so the command will be same. Just I'll limit this to, let's say, 100, and I'll say it's, instead of train, it's validation now. Okay, so just hit enter. It will download the validation dataset of 100 images and labels into the same folder. Okay, just press Y. It will download the necessary files. So now, as you can see, the downloading has begun, and I don't know what this error is, but it will download all the images. It is just some warning. Okay, so now the labels has been created and the validation set has been downloaded successfully. Okay, so let's just see what we get. Dataset. So now we have a validation folder also, and you can see we have the images and the labels. Okay, cool. So now what we need to do next is to edit the classes.txt file. Okay, just open this and include our class. Okay, so make sure the spelling is need to be the same as we have downloaded. Okay, registration plate. This need to be same as the class name inside these labels folder. Okay, here, this. So just inside of this, just copy and go back, and you can just paste it here. Okay, so these two should be same. Okay, so the next step is to run the Python convert annotation. So this file basically converts our labels into YOLOV4 format. Okay, so just run Python conversions annotations.py, convert annotation.py. So right now it is converting for train, and next it will convert for validation set. Okay, so it has been done. So let's see what we get. Let's go to OID, dataset, train, registration. So now you can see each image has this corresponding text annotation file. All right, this. So as you can see, the vehicle registration plate has been converted to 0th class because that is only the class we have right now. Okay, if we had multiple classes, it would be 0, 1, 2, okay, and so on. And also the coordinates are normalized now for the YOLOV4 format. Okay, as you can see earlier, it was vehicle registration plate 233, 297, and now it is between 0 to 1, and yeah, 0 to 1 classes and 0 to 1 coordinates. All right, so if you want to just delete this label folder because we don't need it anymore, so I'll delete it. Okay, and also delete it from the validation set. Okay, so this is our data set. It has been prepared. So the next step is to rename this folder to obj. Okay, so I just needed to close that file before renaming. Rename it obj, and for validation, change it to test. All right, so now what we need to do is, so now we need to zip both the folder, that is the obj and test folder. Okay, so just right click on it and say where is send to, compress zip folder. Cool, now we have a zip folder. Now you can delete this and do the same for the test folder. Okay, send to compress zip folder. Cool. Now what you need to do next is just go to your Google Drive. Okay, and create a folder known as YOLOV4. Okay, and inside the YOLOV4, just drag and drop your these two zip folders, zip files. All right, the test and the obj file into the YOLOV4 folder. As you can see, I've already uploaded it to my Google Drive, so I don't need to do it again. So next step is to create a collab session. All right, as you can see, I've already created a collab session because I trained it previously. So in order to check your NVIDIA GPU of your Google collab session, you can just type this command, and you can see as I have got the Tesla T4 of 15 gigabytes RAM. Cool. So next we need to connect our Google Drive to our Google collab session. So just run this command. Next step is to clone the darknet repository, which will be used to build our darknet YOLOV4 model onto our collab notebook. Okay, so just git clone it. So this is what the output will look like, okay, after cloning it. So next, in order to build the darknet YOLOV4, we need to cd into it, okay, and just run this commands. This will make some changes to the make file. This is just saying that the enable the OpenCV and enable the GPU and QDNN for building our darknet model. Okay, so just hit enter on this cells, and this is in order to check the CUDA version. Okay, as you can see, our CUDA version is CUDA toolkit version is 11. Okay, yeah. Next step is to run the make command, which will actually build the darknet YOLOV4 model onto a collab session. Okay, so let's just hit enter, and we'll meet after the make has been done. Cool. So the the darknet has been built on our collab session. So the next step is to actually copy the folder that I showed you earlier. This obj and test zip files to our Google Colab notebook. All right. So these two commands will just do that. So this will copy our obj and test zip from our YOLOV4 folder to our collab session. Okay. So after doing this, we need to unzip both the zip files onto our Google Colab. Okay. So these two commands will just do that. So this is what that will look like after unzipping both the folders, both the zip files into the data folder. Now, where is this data folder? It's in the darknet repository, okay, that we cloned. Cool. So this is what the output looks like after unzipping. Next step is to copy the YOLOV4 custom.csv to our YOLOV4 folder in the Google Drive. I'll show you what that looks like after using that command. So I'll just go to my YOLOV4 folder, and this is my YOLOV4 obj.cfg that we copied here. All right, that we created. So as you can see, we have this is a CFG file used for YOLOV4 object detection training. So what you need to do is you need to make some changes to the following properties. So as you can see here, max batches should be equal to the number of classes into 2000. All right, so right now we have one class, so it will be 1 into 2000, but the max batches cannot be less than 6000. Okay, so for one class we should always put it assign it as 6000. All right, and the next step is to change the width and height according to the YOLOV4 format. So I'll be using 416 and 416. Make changes in YOLOV4. Okay, yeah. Next steps is to change the steps. Okay, so how do we calculate the steps? So it is the first value is the 80% of max batches, and the next value is the 90% of max batches. Okay, yeah. And the next step is to change the number of classes. Okay, just go with open with text editor. This will allow you to edit it with a text editor, which is provided by the Google Colab itself. Okay, you can make changes here. Okay, so right now I need to find the classes. Okay, we have 3, so just change it to 1. I've already changed it, and above that you need to change the filters. It would be 255 for you, just make it 18. So how 18? Okay, so there is a formula saying that filter should be equal to the number of classes, that is 1 plus 5 into 3. All right, so this is the formula. I'll just type it here, saying that num classes plus 5 into 3. This is the formula. So right now we have 1. So this is the 1 plus 5, that is 6. 6 into 3 is 18. So that is how we got the filters. So do the same for all the classes. All right. Make changes here also, and make changes here also, and here too. Okay. We will have 3 occurrences of classes and filters. Okay, cool. So save this and close the editor. So now you will have the YOLOV4 custom CFG, and the next step is to copy the edited YOLOV4 CFG again to the CFG folder in the darknet repository. Okay, so and now you need to create two files, that is the obj.data and obj.names. So I'll show you the obj.names. Actually, I need to download it. I think we can open it with the text editor. So as you can see, this is the obj.name. Now you can rename the original class name to anything you want, but the order should be same. All right, cool. So I have changed this to number plate. Okay, just close this. So this is the obj.name. So this is the obj.data file. Okay, so these are the five things you need to set. So we have the classes that is equal to 1 obviously, and the train valid data set, which will point to the directory in which the images lie, okay, for both the train and valid set. And the names obviously come from the data and obj.names, and the backup is used to store the weight files when training. Okay, so this is what about the obj.data. Okay, so now we will copy that into the data folder. Cool. Now you can see here we have darknet, and I'll show you that inside the data folder we will have obj and test. Okay, and also we will have here, we can see that obj.names and obj.data is here. Okay, cool. Inside the data folder of darknet repository that we cloned. Cool. So the next step is to create the train.txt and test.txt, as you can see in the obj.data file here. Let me open that. As you can see, it is pointing to train.txt and test.txt. So we need to create these two first. Okay, so with the help of these two files, I will provide the link in the description to these files. Just hit enter and run the next cell, which will actually run these two files to create the train.txt and test.txt. So it has been done. So let's see where we have that. So as you can see here, train.txt, this is what train.txt looks like. Okay, data slash obj slash the image name, all the images. And if we open the test.txt, this is the data slash test slash images name. So the next step is to download the weights of YOLOV4 object detector. This is used for transfer learning purpose. Okay, so we will use these weights and train it and fine tune it on our data set. Okay, so just download these weights. I've already downloaded it. So finally, we have come to the point where we will train our object detector on a number plate data set. Okay, so just put your part wherever you have saved the obj.data and obj and YOLOV4 obj.cfg. All right, and YOLOV4 connet that we downloaded for training purpose. Okay, and let's hit enter. Okay, so we will meet after the training has been done. So this is what the training looked like when I trained it. Okay, so this was all the printing stuff, all the information about the loss, IOU loss, class loss. Okay, so the training has been done, and now we can train the object detector on a custom image. Okay, so I'm using the YOLOV4 obj last weights. Okay, this is the command. This is all has been provided in the description. So let's just run it. It has been done. So what I will do that it is, I think here, this is the file that it has predicted. So we will open it, and as you can see, it has detected the number plate at 99% accuracy. Isn't that great, guys? Okay, so next we will test another image. I'll say that I have 3 images to be tested on. Let's say T1, and we'll run the detection. Okay, so it has also detected the number plate and at 98% accuracy. So let's just see that predictions. So yeah, so as you can see, it has greatly predicted the number plate. Okay, as you can see, 98% it is number plate. That's cool. Okay, another image I have in order to test this. So I think it's T3 dot shape I guess. Yep. Okay, we have got our prediction at 70%. So let's see. Actually, it has detected in a very great, right? It's really great. All the bounding boxes just covers the number plate. All right. So yeah, this is all for this tutorial, and I hope you enjoyed it. Thank you.